Good evening, children. Good evening.
Good evening.
Good evening, children.
Good evening.
Good evening. So today you are going to teach me trigonometry. Just revising, I'm just going to pick questions from different parts of the chapter trigonometry. Let's see how much you've understood. Evaluate, all right? One by 4. Yes, children. Yeah, please work this and tell me the answer. Now here, will you use the concept of trigonometric identities or complementary ratios, reciprocal ratios, or will you pull the values from the table? Look at the angles. Are they standard angles?
Yes, ma'am.
They
Yes,
are
yes.
standard angles. Yeah, they are standard angles. 30, 60, 45, 30, 60. So use the table and get the values from the table. What is the value of cot 30? What is cosecant 60? What is secant 45? From the table, what's the value of tan 30? What is the value of cos 60? Now, when it is cot 30 to the power 4, whatever is the value of cot 30, raise it to the power 4. So this is just simplifying, meaning just it's about numbers, LCM. Tell me, I'm not working this, I'll only give you the final answer. Yeah, I have the final answer with me. Please work, children. Done, children? Yeah.
Ma'am, is the answer -1/2, ma'am?
No. Let me check if I've written it correctly. 1 by 4 cot 30 to the power 4 minus cosecant plus 3 by 2 secant tan squared minus 5 plus 60. Yeah, I've written it right. I have a different answer with me. Please check. Okay, let me try. 1 by 4. What's the value of cot 30? Root 3, right? Yeah, minus cosecant 60. 2 by root 3. Correct. Plus 3 by 2 into secant square 40, secant 45. Root 2. Root 2. Very good. Tan 30.
1 by root 3.
1 by root 3. Oh, 1 by root 3. Yeah. Cos 60.
1 by 2.
1 by 2. Okay. So this is 1 by 4. And in the bracket, this is going to be, what's the value of root 3 to the power 4? 9. 9. Root 3 into root 3 is 3. Another root 3 into root 3 is 3. 3 3s are 9. Minus, this one is going to be 16 by
9.
9. 16 by 9 plus 3 by 2 into 2. Root 2 square, root 2 into root 2, 2 minus 1 by 3 minus 5 into 1 by 4. Okay, so that's 1 by 4 into 9 9s are 81. 81 minus 16. Minus 16. How much is it, children? It's 65. Is it 65 by 9, children? Okay, 65 by 9. Okay. Plus 3 by 2 into 6 minus 1, 5. 5 by 3. Let me write it straight away. 5 by 3 minus 5 by 4. So this is going to give us 65 by 9 4 are 36 plus 3 cancels here. So 5 by 2 minus 5 by 4. Am I right? Yeah, so far, children.
Yes, ma'am.
Yeah, so next, let me continue here. Let me just continue here. See here, I'm writing is equal to common denominator 36. Okay, 36 is the common denominator. So 65 plus 18 fives are 90. 18 fives are 90 minus 9 fives are 45. So 65 minus 45. 65 minus 45?
20.
20 plus 20, right?
Yes, ma'am.
Plus 20. And 90 plus 20 is 110. So it's 110 by 36. And on simplifying by 2, we get 55 by 18. And this is the answer I have with me. 55 by 18. Yes, I'm right. Now, children, please check where you have gone wrong and please get your doubts clarified. See, this 1 by 4 is to be multiplied with the answer for this bracket. 1 by 4 is to be multiplied with the answer you get in this bracket. 3 by 2 is to be multiplied with the answer you get in this bracket. After simplifying this bracket, whatever answer you get, that into 3 by 2. So you can see here, 1 by 4 into this value after simplifying this bracket. Just please ask me, children. Where you don't understand, please ask me. Okay, next question. Since Nandini shared her answer, Nandini, can I help you? Or you found your mistake?
I found him. I went wrong in the simplification part.
Yes, darling, we need to take care. Yeah. Okay, over to the next one. Yeah. Next one, same heading, children, evaluate, but now the angles are not standard angles. In this question, all the angles were standard angles, so you could pull the values from the table. Okay, so the same heading, evaluate 2 by 3 cosecant square 58 degrees minus 2 by 3 cot 58 tan 32 minus, my God, what is this minus? Not visible almost. Just a minute, children. Let me check what it is. Oh, okay. Just a minute, children. Two by three. It's 2 by 3. Actually, it's 2 by 3 cosecant square 58 degrees minus 2 by 3 cot 58 degrees tan 32 degrees minus 2 by 3 tan 13 degrees tan 37 degrees tan 45 degrees tan 53 degrees. Continue. I don't have place, so I'm writing down. Tan 53 degrees, tan 77 degrees, tan 77 degrees. Yeah. Tan 53. Yes, children. So there is only one standard angle here, 45 degrees, whose value you can get from the table, tan 45. You can get its value from the table. The others are non-standard angles, 58, 32, 13, 37, 53, 77. Let's try. I'll not disturb you for 3 minutes. Please try, children. I'll just come back. Yes, what's the answer? What is the answer, children? Please share your idea. See, don't hesitate. Whatever you have in your book, whatever you've tried, if it's incorrect, I can tell you where you've gone wrong. No idea? I've asked you so many questions. I haven't got one answer so far. This is also no answer. Okay. Okay. So all of you are measuring my patience, right? So how much do you give me for 10? Yeah. From a scale of 1 to 10, if 1 is very bad and 10 is very good, how many marks do I get for patience? Yeah, children, that also no answer. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes.
Very good, very good. Okay, fine. All right, children. So this is what we need to do. Happening. 1 minute, children. Yeah. Hello. So what we need to do is we need to first plan, you know. So now here we have cosecant square 58 degrees. And here we have cot 58. You know how we wish this was cot square 58. Then cosecant square 58 minus cot square 58 will be 1. See, you can take out 2 by 3 common. We are talking about the first two expressions. Yeah, children. So we are talking about the first two terms. We can take out 2 by 3 common. And this one is cosecant square 58. And we wish this was cot square 58. So we have one cot 58 here. So this also we want, if this is also cot 58. Yeah. There is some plumbing work going on in my house, children. Yeah. So now we wish this were, cot square 58. We have one cot 58. So we'll make this one also cot 58 so that cot 58 into cot 58 will be cot square 58. All right. So minus, as of now, we'll just take out 2 by 3 common. So cot 58 degrees, tan 32 degrees. Okay, minus 2 by 3. Here we have, it's product everywhere. See, it's tan 13 into tan 37 into tan 45 into tan 53 into tan 77. So we have to group, the ratios so that their angles are complementary. So 13 and 77 complementary angles. 13 plus 77 is 90. 37 and 53. 37 plus 53 is 90. Tan 45 can stand alone because its value is 1 from the table. All right. So now we are going to write tan 13 degrees and tan 77. Then tan 37 degrees with tan 53. and tan 45 stands alone. Okay, next step, 2 by 3 into cosecant square 58 degrees. See, we already planned. The idea is we have cosecant square 58. We want cot square 58. We have one cot 58. So we are now trying to make this also cot 58. So let's see how we can do that. Cot 58. Tan theta is cot 90 minus theta. Tan 32 is cot 90 minus 32. Tan theta is cot 90 minus theta. So tan 32 is cot 90 minus 32. Yes or no, children? Tan 32 is cot 90 minus 32 minus 2 by 3. Now change one of the two. Here change any one of the two. Don't change both. Change one of the two. So supposing you keep tan 13 as it is. Tan 13 as it is. Now tan 77. Tan theta is cot 90 minus theta. So tan 77 is cot 90 minus 77. Then supposing you keep tan 37 as it is. Tan 53 is cot 90 minus 53. And the value of tan 45 is 1. So into 1. So in this pair, change any one of the two. Any one of the two. So in this pair, I've changed tan 77. And in the other pair, I've changed tan 53. See, you can change tan 37 also. Not that you should change the second one in both. Nothing like that. Any one of the two. Am I audible, children?
Yes, ma'am.
Yeah. All right. So now let's proceed. So 2 by 3 into cosecant square 58 degrees minus what is 90 minus 32? 90 minus 32 is 58, cot 58. And cot 58 into cot 58 is cot square 58. That we'll get in the next step. So let me write cot 58 into cot 58 into cot, or so you can simply write cot 58. Close the bracket. Minus 2 by 3 tan 13 degrees cot 13 degrees. Tan 37 cot 37 into 1 goes away. 2 minus 2 by 3 tan 13 90 minus 77 is 13 cot 13. Tan 37 cot 37. 90 minus 53 is 37. So next step 2 by 3 into cosecant square 58 degrees minus cot square 58 degrees minus 2 by 3. Now tan and cot are reciprocal ratios. So you can write tan 13 as 1 by tan 13. 1 by cot 13 into cot 13. So they get cancelled. Okay. So 2 by 3 into 1 by cot 13 into cot 13. Again. So yeah. So now you can write tan 37 as 1 by cot 37 into cot 37. So what happens? They get cancelled. Cot 13, cot 13, cot 37, cot 37. They get cancelled. So what do you have? On this side, you have 2 by 3. You have, let me write it here. I can't write that extreme left. I cannot write. Is equal to 2 by 3 into 1. Cosecant square theta minus cot square theta is 1. Minus 2 by 3. Minus 2 by 3. There also it's everything gets cancelled. So 2 by 3. So 2 by 3 minus 2 by 3, which is 0. 2 by 3 minus 2 by 3, which is 0. So the latter half, that is the second part of the expression, you will change tan to cot. That is, you will first use, complementary ratios and then reciprocal ratios. In the first part, you take out 2 by 3 common. And since you have cosecant square 58 degrees, you want the second part to be, that is the cot 58 tan 32 to become cot square 58. Because cosecant square theta minus cot square theta is 1. So plan that and execute your plan. Yeah, please work. Done, children? Finished writing?
One minute.
Yeah. I'm going to work the same thing in a different way for you. That is only the first part. Okay, the second part also, we can work it in a different way. Let me show you that. Please let me know, children, if you have completed writing this one.
Completed, ma'am.
All right.
Yes, ma'am.
All right. Yeah. Now let's use a different identity. Now I'll just write the same thing again. 2 by 3 cosecant squared 58 degrees minus 2 by 3 cot 58 tan 32 minus 2 by 3 tan 13 tan 37 tan 45 tan 53 tan 77. Okay, so again we look at this whole expression in two parts. This is the first part. This is the first part till here, and from here is the second part. The second part. All right. Now the first part earlier, we were here in this method. We converted the first part to look like the identity cosecant square theta minus cot square theta, which is 1. Now you can also change it to secant square theta minus tan square theta, which is 1. Secant square theta minus tan square theta, which is 1. So you fix the idea, and it should be possible to change. That's another thing. Now here we have tan 32. We have tan 32. Okay, so this one, we know that cosecant and secant are complementary ratios. Cosecant and secant are complementary ratios. So what you can do is, you know that you can change cosecant to secant because cosecant and secant are complementary ratios. So you can change cosecant to secant And you can change cot to tan. Again, because they are complementary ratios. So that way you can bring the identity secant square theta minus tan square theta, which is 1. So first you plan and then execute your plan. You need to plan first. You cannot just start working. If it's a numerical expression, yeah, you have to start working to know what will come next. But here you have to first plan. So now what our idea now here is, we'll convert the first part to look like secant square theta minus tan square theta. All right. So as we did earlier, we have to first take out 2 by 3 common. So we have cosecant square 58 minus cot 58 tan 32. I'm just taking out 2 by 3 common now. Cosecant square 58 minus cot 58 tan 32. Close the bracket. And minus 2 by 3. Here again, we group the ratios where the angles are complementary. So tan 13 goes with tan 77 because 13 plus 77 is 90. Then tan 37 goes with tan 53 because again 37 plus 53 is 90. And tan 45 stands alone. And we can get the value of tan 45 from the table, which is 1. All right, so that's over. The second part is also done. Now, 2 by 3. What's the idea? To change this expression to secant square theta minus tan square theta. So cosecant square theta is secant square 90 minus theta. Cosecant square theta is secant square 90 minus theta. So see, secant square 90 minus theta, which is 58. Read this. Cosecant square theta, which is 58, is secant square 90 minus 58 minus. So we have successfully changed cosecant square theta to secant square theta. Now tan square theta, secant square theta minus tan square theta. So let this tan 32 remain. Don't change that because you want tan square. So there is one tan 32. Change cot 58 to tan. So we know that cot theta is tan 90 minus theta. Tan 90 minus theta, which is 58. Correct? Cot 58, cot theta is tan 90 minus theta, tan 90 minus 58. So we have converted this cot to tan. Write this tan 32 as it is. Write tan 32 as it is. See, the identity is secant square theta minus tan square theta. So if you have a tan, have it as it is. Cot, you change it to tan. Okay. And cosecant square, we change it to secant square theta. All right, now the second part, minus 2 by 3. Now earlier, I first applied the concept of complementary ratios and then reciprocal ratios. You can also do reciprocal ratios first and then complementary ratios. Let me show that now. So into, you can change any one of the two. See, this one, am I audible, children?
Yes.
Yeah. So you can, this is the pair tan 13 and tan 77. Here tan 37 and tan 53. All right. So now earlier here we used complementary ratios first and then reciprocal ratios. Now we'll use reciprocal ratios first. Okay. So change any one of the two. Change any one of the two. Which one do you want to change? Tan 13 or tan 77?
Tan 13.
Tan 13. Okay. What's the reciprocal of tan theta?
1 by cot
1 by cot theta. So tan 13 degrees is equal to 1 by cot 13. Tan theta is equal to, see, tan theta is not equal to cot theta. Tan theta is not equal to cot theta. Tan theta is equal to 1 by cot theta. So 1 by cot 13. Then don't change 77, write that as it is. Write that one as it is. Okay, now again here, any one you can change. It's into, children. If I don't write any sign, it's multiplication. Now, supposing you write tan 37 as it is, and you write tan 53 as 1 by cot 53. And children, there's no place, tan 45 is 1 into 1 into 1. Tan 45 is 1, so into 1. All right, now 2 by 3 into, this is going to be secant square 90 minus 58, which is 32, minus tan 32, because 90 minus 58 is 32 into tan 32, close bracket, minus 2 by 3 into, now use the concept of complementary ratios. Complementary ratios. Now, again, anything you can change. You can change cot 13 or, tan 77. Anybody you can change. Again, that's your choice. So supposing I change cot 13. What is cot theta? Cot theta is tan 90 minus theta. Tan 90 minus theta. So 1 by cot theta is tan 90 minus 13 minus theta into tan 77 into, supposing you write tan 37 as it is, into 1 by cot 33, cot 53. Cot theta is tan 90 minus theta, 90 minus 53. You have to write it in the same straight line, children. I don't have place, so I've written it down. So now this becomes 2 by 3 into secant square 32 minus tan square 32, minus 2 by 3 into 1 by tan 77 into tan 77 into tan 37 into 1 by tan 37, because 90 minus 53 is 37. You can see they get cancelled. And here secant square theta minus tan square theta is 1 minus their, tan 77, 77, they get cancelled. So you have 2 by 3 into 1 into 1. So it's 2 by 3. So 2 by 3 minus 2 by 3, which is 0. So this way is also fine. Yes, children, please write down. Please come back, children. Please write. This is the next one. So prove this trigonometric identity. Prove the identity. Prove the identity. All right. Cosecant theta plus cot theta divided by cosecant theta minus cot theta is equal to 1 plus 2 cosecant theta cot theta plus 2 cot square theta. Yeah. Why shouldn't? Cosecant plus cot, yeah. Correct. Yeah, please try, children. Got it? Very easy, children. Got it? Pranav, you got it, is it? You've raised your hand?
Ma'am, technically.
Okay, okay. Okay. No, I don't want to waste time. Nobody is responding. So we need to observe, the identity given. You can see the RHS does not have a denominator at all. The RHS does not have a denominator. So that means when you work with the LHS, when you work with the LHS, the denominator should become 1. Now in the LHS, you have an expression in the numerator and the denominator. See, one thing is you need not change on the LHS. You need not change cosecant and cot to sine and cos, because you can see the RHS is made up of cosecant and cot only. Then why do you change it to sine and cos? Because the general rule is change other t ratios to sine and cos, or sine or cos. So we're not going to use that here, because The RHS is also made up of cosecant theta and cot theta. LHS has cosecant and cot. Then why change? Work as it is. But what that difference which we notice is in the LHS we have a denominator which is not 1, but in the RHS the denominator is 1. So which means you have to get rid of the denominator. You have to get rid of the denominator. And how can you get rid of the denominator? By making it 1. And how can it become 1? If it is cosecant square theta minus cot square theta. It is now cosecant theta. Now what is the LHS? What is the LHS? The LHS is cosecant theta plus cot theta divided by cosecant theta minus cot theta. Now this is the denominator. Now the denominator should be 1. So what should you multiply it with? You should multiply it with cosecant theta plus cot theta. Why? Because a plus b into a minus b is a square minus b square. Cosecant square theta minus cot square theta. And what is cosecant square theta minus cot square theta? 1. So that way the denominator can become 1. And that is why we multiply with cosecant theta plus cot theta. So do the same thing in the numerator, cosecant theta plus cot theta. That's the first thing. Now the numerator becomes a plus b into a plus b is a plus b the whole square. A plus b the whole square. While the denominator is a plus b into a minus b, which is a square minus b square. The numerator is a plus b into a plus b the whole square. Denominator is a minus b into a plus b, which is a square minus b square. So that is 1. So in the next step, we'll expand the numerator because you can see the RHS. It has, 2 cot square theta and stuff like that. So let's expand and see what happens. So a plus b the whole square is a square cosecant square theta, a square plus b square. That is, or you can write 2ab. You can write 2ab. Okay, so 2ab, 2 cosecant theta, cot theta plus b square. Plus b square meaning plus cot square theta. Now tell me, after this, how do we arrive at the LHS? I mean RHS. By 1 children, so I have not written that. Denominator is 1, it's gone. We have not still arrived at the RHS. Now what should I do? We are close. You can see what do you need? You need 2 cosecant theta cot theta. So let that remain. And there is cot square theta also in the RHS. So let that remain. What is not there in the RHS? What is not there in the RHS? Please answer. We have got something.
Cosecant square theta, ma'am.
Yeah. What is not there?
Cosecant square theta, ma'am.
Cosecant square theta. Is it Priyanka or Rajarajeshwari?
Rajarajeshwari, ma'am.
Okay, okay. Very good, Rajarajeshwari. Very good. Cosecant square theta. When you look, see, we have arrived at some point, but when you compare that with what is actually in the RHS, we notice that the RHS does not have cosecant square theta. So you have to get rid of it. And how will you get rid of it? What can you replace that with? Cosecant square theta. See, you have 2 cosecant theta, cot theta, same thing here. Cot square theta is there. It's 2 cot square theta, but there is cot square theta. So let that remain. This cosecant square theta is nowhere in the RHS. So we're trying to replace it by something else suitably. What is that?
One plus cot square theta.
Very good, Kanishka. 1 plus cot square theta. Cosecant square theta is equal to 1 plus cot square theta. Because the RHS does not have cosecant square theta. So we have to take it away. And how can you take it away? But you should not write the reciprocal ratio. Don't write cosecant square theta as 1 by sine square theta. That's of no use here. Or don't use complementary ratios. Cosecant square theta is secant square 90 minus theta. How is it going to help you? So cosecant square theta is equal to 1 plus cot square theta, and write the rest as it is. Write the rest as it is. As it is. Now you get 1 plus, we'll write it in the same order as it is in the RHS. So 1 plus 2 cosecant theta cot theta, and cot square theta plus cot square theta is 2 cot square theta. Cot square theta plus cot square theta is 2 cot square theta, which is equal to the RHS, hence proved. Yes or no? Yes. Yeah, please write down, children. Please write down. Done, children.
Complete.
Completed, ma'am.
Feel nice by doing a similar one quickly. Work it very quickly and tell me you got it. A similar situation. Secant theta minus tan theta divided by secant theta plus tan theta is equal to, see the RHS is equal to 1 minus 2 secant theta tan theta. So see, LHS has secant and tan, RHS also has secant and tan, then don't change. Plus 2 tan square theta, very similar to the earlier one. That was in terms of cosecant and cot. This is in terms of secant and tan. Yeah, try this. I'm working, but you don't look at the screen. You copy the question and do it by yourself. Heading is the same. Prove the following identity. Let's see who finishes first, me or you. Divided by 1, so I'm not writing that. Kanishka finished?
Yes, ma'am. Completed.
Very good. You got it right?
To complete.
Yeah, how many of you finished? Raise your hand. Kanishka, very good. Harini, Sneha, Priyanka, Sashmin, very good. Kanishka, why hands up and down? Kanishka, Harini, Sneha. Oh. Okay. Class, use the emoji. All of you raise your hand. Netra, are you there?
Yes, ma'am.
All right. Yes, children. So this was a similar one. Again, same heading, prove the, trigonometric identity. I'll give you a very interesting one. Yeah. 2 secant square theta minus secant theta to the power 4 minus 2 cosecant square theta plus cosecant theta to the power 4 is equal to cot theta to the power 4 minus tan theta to the power 4. We'll do this together. Prove the identity, prove the trigonometric identity is the heading. We need to take up the LHS and see if we can get the RHS. If we don't get the RHS, then we have to work the RHS and show that the LHS is equal to the RHS. All right. Now, you can see, okay, we see that on the LHS there are 4 terms. And when you observe the terms carefully, look at this secant theta to the power 4. Don't consider the sign now. Secant theta to the power 4 and then 2 secant square theta. So like a squared 2ab. Then that b square should be 1 only because the 2ab does not have anything else. It's only 2 secant square theta. The b term, you don't find anything different. So it should be 1. It should be 1. So secant theta to the power 4 like a square and 2 secant square theta like 2ab. So that b square should be 1. And here cosecant theta to the power 4 like x square. And 2 cosecant square theta like 2xy, x square plus 2xy. Then that y square should be 1. Because 2ab, 2 into a is cosecant square theta. B, you don't find b there. So it should be 1. So imagining this, see, we don't know. So, but this is a kind of an intuition we get when we see this expression. If you regard this as x square, then this is your 2xy. Then the y square should be 1. And if you regard this as a square and this one as 2ab, then the b square should be 1. Okay. So with this idea, let's get started. LHS, see here is equal to, first let me write as it is, like this, as it is. Then we'll consider the signs and then rearrange. Considering the signs, we'll then rearrange. Yeah, now we'll write this one first because this is minus secant theta to the power 4. See, you cannot change the signs throughout because it's an expression. In an expression, you cannot change the signs throughout. When you're working with an equation, then you can change the signs in the LHS and the RHS. In an expression, you cannot change the signs throughout. You cannot change the signs. In an equation, you can change the signs on both the sides. Here, you cannot do that. So we'll rearrange. So since this is minus secant theta to the power 4, let's write this one first. Cosecant theta to the power 4. Then minus 2 cosecant square theta. Then this minus secant theta to the power 4 and plus 2 secant square theta. So we have grouped a square to ab, a square to ab. B square is not there. Okay. Now this is in the bracket cosecant theta to the power 4 minus 2 cosecant square theta, meaning we are grouping these two. And here we are grouping these two. But when you take a minus outside, it's going to be minus here 2 secant square theta. We have now comfortably grouped. We have in one bracket, we have a square minus 2ab. In the other bracket also, we have something like x square minus 2xy. See, when you take the minus in between common, that plus becomes minus. This plus becomes minus. Minus into minus plus. Now see here, we are going to introduce that b term. We're going to introduce that b term. See here, cosecant theta to the power 4 minus 2. Okay, 1 minute. 1 minute. Let me not repeat. Let's write something new. Every step should have something new, right? So let's write this one as cosecant squared theta the whole square minus 2 into cosecant 2 into cosecant squared theta into 1 plus 1 the whole square. You will understand, children. I'll explain. Minus, I think I'll not have place. 1 minute. Let's write it again. Is equal to square bracket cosecant squared theta the whole square minus 2 into cosecant squared theta into 1 plus 1 the whole square, close bracket, minus secant squared theta the whole square minus 2 into secant squared theta into 1 plus 1 the whole square. Now, what have we done in both the brackets? Suddenly, we've introduced 1. There was no 1 at all. See, this one is cosecant theta to the power 4, which is already there. And this one is 2 cosecant square theta, which is already there. How did we write 1 all of a sudden, 1 square? Just because we want to complete the square. If we have 1 square, you can complete the square. Meaning you have a square and minus 2ab. You don't have that b square term. If you write plus b square, you're completing the square. So you can write it as a minus b the whole square. Okay. And in the second bracket also, this one is there. Secant theta to the power 4, we have it there. And this one is 2 secant square theta, which also we have. But this plus 1 square, again, what we've done there in the second bracket is, since we have, meaning to complete the square, we don't have the b square term. We want to complete the square. We want to write it as x minus y the whole square. But for that, you need 3 terms. 1 x square, 1 minus 2xy, and plus y square. That y square term is missing. So we have simply written plus 1 square. But now you can see that in the first bracket, we have written plus 1. In the second bracket also, we have written plus 1. But when you use it with a minus outside, it's minus 1. So it's like plus 1 minus 1. So though you have written plus 1 square in both the brackets, it's like 1 minus 1, 0. You have not made any change in the expression. I repeat, this plus 1 square is 1. In the next bracket also, you have plus 1. But there's a minus outside here. So it's like 1 minus 1. See, this is 1. And minus 1 here. Minus 1. Minus 1 meaning it's like plus 1 and minus 1. 0. So you have not made any change. Though you've added the b square and the y square term to both the brackets, the effect is nullified. 1 square minus 1 square. 0. 1 minus 1, 0. So you have not made any change in the expression. Though it visibly looks different, by value it is not changed. Agree with me, all of you?
Yes, ma'am.
Okay, thank you. Yeah, now we'll complete the square. So we did that to complete the square. Now let's complete the square. Now this is like a square minus 2ab plus b square, which is a minus b the whole square. This is a, children. This is a minus b the whole square. A square minus 2ab plus b square. It's a minus b the whole square because minus 2ab. This is in one bracket minus. The next one is like x square minus 2xy plus y square, which is x minus y the whole square. This is x. This one is x minus y the whole square. X minus y the whole square. X square minus 2xy plus y square. X minus y the whole square. X is secant square theta, y is 1. Now cosecant square theta minus 1 is cot square theta, the whole square, minus secant square theta minus 1 is tan square theta, the whole square. Now this is 2 into 2, 4. So cot theta to the power 4 minus tan theta to the power 4, which is the RHS, which is the RHS. Very nice idea, you know. So the idea is good. The idea is beautiful. So please work it a few times, children. See, we understand once in the class, but you need to practice to remember all this. Write down. Yeah, next one is also very interesting. Yeah. Done, children?
One minute.
Yes, ma'am.
Yeah, yeah. Okay, okay. Done, children?
Yes, ma'am.
All right. Simple but interesting. See this one. Express sine cube theta plus cos cube theta divided by sine theta plus cos theta plus sine theta plus cos theta as an integer, as an integer, as an integer. Express this one as an integer plus sine theta cos theta. Oh, plus sine theta cos theta. I'm so sorry. Plus sine theta cos theta as an integer. Sin cube theta plus cos cube theta sin theta plus sin theta cos theta. Just a minute. Yeah. So you should actually do it in your mind. The numerator is see, this is not proving the identity. There is no identity here. It's only an expression. It's not an equation. An identity is an equation. Whether it is an algebraic identity or a trigonometric identity. An algebraic identity will have variables. A trigonometric identity will have trigonometric ratios. Now, when we say secant square theta minus tan square theta is 1, it's a trigonometric identity because it's an equality. There is LHS, there is RHS. There's an equality. An identity is an equality. An identity is an equality. It will have the LHS and the RHS. And secant square theta minus tan square theta is equal to 1 is an equality which has trigonometric ratios. It's a trigonometric identity because it holds good for all values of theta. Now, a plus b the whole square is a square plus b square plus 2ab is an algebraic identity because it's an equality. You can see the LHS and RHS. A plus b the whole square is equal to, it's an equality, is equal to a square plus b square plus 2ab. So an identity, an algebraic identity is an equality and it involves variables. An algebraic identity involves variables and it's an identity because it's true for all the values of the variables involved. Whatever be the values of a and b, the identity holds good. Now this one is not an identity, it is an expression. You'll have to work this and show the answer is an integer. So the answer can be like 0, 1, minus 1, 3, 7 by 5. Can it be 7 by 5? Can the answer be 7 by 5? It cannot be 7 by 5 because 7 by 5 is not an integer. Okay. Now let's work this. To work this, look at the numerator and the denominator. A cubed plus b cubed. A plus b. And we all know that a cubed plus b cubed is, okay, let me write it here. Tell me the identity. What is a cubed plus b cubed? What is a cubed plus b cubed? A cubed plus b cubed is equal to a plus b completed is equal to a plus b into a plus b into, yeah, a plus b into what? Oh my God, is the class sleeping? What happened, children? Complete the identity. A cubed plus b cubed is equal to a plus b into what?
A square plus AB plus B square.
Very good. Thank you, Tarun. Tarun Murali. A square minus AB plus B square. A cube plus B cube is equal to a plus b into a square minus AB plus B square. Not minus 2AB, minus AB. So use this identity here. Use identity. So this will be sin theta plus cos theta into sin square theta minus sin theta cos theta. There's no place. So let me squeeze plus cos square theta divided by sin theta cos theta, sin theta plus cos theta, plus sin theta cos theta outside, plus sin theta cos theta. Now this gets cancelled. So we are left with sin square theta minus sin theta cos theta plus cos square theta plus sin theta cos theta plus sin theta cos theta. So this gets cancelled. So sin square theta plus cos square theta, which is 1. And 1 is an integer. So we have expressed as an integer. So the value of the given expression is 1. 1 can also be written as You can write 1 as sine cube theta plus cos cube theta plus sine theta plus cos theta plus sine theta cos theta. That is 1. The value is 1. Making use of this identity. And how do we know that we have to use this identity? Because it's very clear. Look at the numerator, a cube plus b cube. And look at the denominator, a plus b. Isn't it? Doesn't it sound, what do I say? When you read it, if you know the identity, you will be able to relate it. So a cube plus b cube, you should know is a plus b, a square minus ab plus b square. Denominator is a plus b. So we use the identity so that you can cancel out a plus b and a plus b. Got it, children? Any questions?
No, ma'am.
All right. Just do one more and wind up the session for today. So this is find x. Find x. Find the value of x. If find x, if find x, if root 3 by 2 tan 2x is equal to cos 60 degrees, cos 30 degrees, plus sine 60 degrees, sine 30 degrees. Yeah. Yeah. So find x. We need to find the value of x. You can see x here in 2x. You can see x there. So let's write out what is given. Root 3 by 2 tan 2x is equal to, this is what is given to us, cos 60 degrees, cos 30 degrees, plus sine 60, sine 30. Now, this is root 3 by 2. Nothing can be done here. Tan 2x, nothing can be done here, is equal to, what's the value of cos 60?
1 by 2.
1 by
2.
2. Cos 30?
3 by root 3 by 2.
Root 3 by 2. Plus sine 60?
Root 3 by 2.
Root 3 by 2. Sine 30?
1 by 2.
1 by 2. So root 3 by 2 tan 2x, nothing can be done here, is equal to multiply root 3 by 4 plus root 3 by 4. Root 3 by 4 plus root 3 by 4. So root 3 by 2 tan 2x is equal to, what is root 3 plus 4 by root 3? Sorry, what is root 3 by 4 plus root 3 by 4? What's the answer?
2 root 3 by 4.
Yeah, 2 root 3 by 4. Very good, Kanishka. 2 root 3 by 4. Root 3 by 4 plus root 3 by 4. When you take the LCM, 4 is the common denominator. What will you get in the numerator? Root 3 plus root 3. What is root 3 plus root 3? 2 root 3. 2 root 3 by 4. 2 root 3 by 4. 1 minute. So root 3 by 2 tan 2x. Root 3 by 2 tan 2x is equal to 2 root 3 by 4. Is equal to 2 root 3 by 4. So here you can cancel 1, 2. So root 3 by 2 tan 2x is equal to root 3 by 2. You can transpose this. This is nothing but root 3 by 2 into tan 2x into tan 2x. So you can transpose that. You can transpose tan 2x is equal, or you can simply cancel it on both the sides. Tan 2x is equal to root 3 by 2 into 2 by root 3. So they get cancelled, root 3, 2, 2. So tan 2, see children, tan 2 in tan 2x, 2 you cannot separate. Tan 2x is not tan into 2 into x. Tan of this angle, 2x, tan and 2x are not separable. Tan of this angle 2x. So you get tan 2x is equal to 1. Tell me what next? We need to find the value of x. After this, what? Tan 2x is equal to 1, then
2x is equal to 45, ma'am.
correct, but correct, you're right, very good. But how can I suddenly write
Tan
2x is equal?
45, ma'am.
Tan 2x is equal to, very good. Tan 2x is equal to,
Tan 45, ma'am.
very good. Tan 45. Instead of 1, you should write tan 45 because tan 45 is 1. Now on comparing both the sides, you cannot cancel tan and tan. On comparing both the sides, 2x is equal to 45 degrees. X is equal to 45 by 2, which is 22 and a half. So the value of x is 22 and a half degrees. The value of x is 22 and a half degrees. Yes, children? Write down. Done this slide, children? Okay. Done, children?
Yes, ma'am.
All good.
This one.
Not explaining this. I'm just going to work it very quickly because it's time. Just write down and you should be able to understand it by yourself. Write down, children, quickly. So we found the value of theta, which is 45 degrees. So now you can evaluate anything. You can find anything. We found the value of theta. LCM, cross multiply all the terms on one side. They look like a square minus 2ab plus b square, which is a minus b the whole square. There you should not go wrong. A square minus 2ab plus b square, which is a minus b the whole square. So a minus b is 0. That means tan theta is equal to 1. 1 is tan 45. So theta is 45 degrees. Now how will we find? How will we find? So now tan theta to the power 7 plus 1 by tan theta to the power 7 is equal to tan 45 degrees to the power 7 plus 1 by tan 45 degrees, because theta is 45, we found it, to the power 7. So now this is nothing but tan 45 degrees, the whole power 7. That's the meaning. That's the meaning. Plus 1 by tan 45, the whole power 7. So we know that tan 45 is 1 to the power 7 plus 1 by 1 to the power 7, which is 1 plus, it's 1, children, 1 plus 1, all right, which is 2. So whatever be the power of, tan theta can be 100, 200, whatever, don't get scared. It can be 2, 3, 4, 5, 6, whatever be the power, the value is always 2. See, tan square theta plus 1 by tan square theta is also 2. Tan cubed theta plus 1 by tan cubed theta is also 2. Whatever be the power of, tan theta here, the value will always be 2. Very interesting question. Let me show you this slide if you have not completed. Find the value of theta and remember, whatever be the power, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 1000, whatever be the power, here in this case, the value of the expression will always be 2. 1 plus 1, 2. Finish writing, children? I don't know which slide to show. Maybe you can take a screenshot. Take a picture and you can complete it. I don't know which one to show. I've continued like this, children. After this one, I went here. I worked here. Tan theta is equal to 1. Yeah, take a picture. Take a picture. Yeah. All right, children. So at the end of the session, we have 11 students. Lower your hands and raise your hands again, children. Please kindly lower your hands and raise your hands again. All of you. Lower your hands. All of you, lower your hands. Lower your hands, children. Sashmin, Priyanka, and Harini, Sneha, lower your hands. So you're not there. Harini, Sneha. Okay. Priyanka, you're not there. Are you there, Priyanka? I don't know. All right. Now, class, raise your hand. Okay. Kanishka, Netra, Tarun Murali, Ramnathan, Ananya, Murali Krishna, Sashmin, Rajarajeshwari, Harini, Sneha, and Nandini. Very good, children. All right. I hope today's session was very useful and interesting. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you.
Thank you.
Thank you. Good night.